a value for an expression, the problem is usually directing you to substitute numbers in for variables. Now, I know sometimes I'm guilty of saying like plug in numbers for variables, but the technical term would be substitute, and they might even say substitute, so I'm going to try to use that word instead. The expressions can be simple or complex. The key to remember after you plug values in for the variables is to remember your order of operations. What's the little phrase that you guys use for remembering the order of operations? Please excuse my dear Aunt Sally. So we have P, E, M, D, A, S. That tells you what order to go in. So you always start with parentheses. Then if there's any exponents, you evaluate the exponents. Then you do all multiplication and division left to right, and then you do all addition and subtraction left to right. So that's the order you go in. If you go out of order, you will not get the correct answer at the end. And so really, when they're asking you to do this type of problem, they're just making sure and checking that you know how to do order of operations. So let's go ahead and write. I'm going to write down an expression, and I'm going to tell you some numbers that we're going to plug in. Let's go with 3x. Then I'm going to tell you that x is 2 and y is 4. Now, they would have this information in a paragraph of some sort, but the paragraph would say something like, evaluate this expression for the values of x equals 2 and y equals 4. So you would see this, that would jump out at you, and you would see that x equals 2 and y equals 4. Now again, if it says evaluate, all it's doing, or all it's asking you to do, is substitute these numbers in for x and y. So my suggestion right off the bat is just do that. Don't try to skip steps. But wherever you see an x, we're going to put a 2. Wherever you see a y, we're going to put a 4. Now, I know there's lots of parentheses going on there, but we don't want to automatically do an operation without actually making sure we're going in order. Okay, so you have this expression out in front, and then this parentheses is being raised to the second power. So in order of operations, you have to deal with parentheses first. And when you do parentheses, that means anything in the parentheses you have to figure out before you move on to the rest of the problem. So inside the parentheses, we have a multiplication, a subtraction, and another multiplication. So we have to do multiplication first before we do addition and subtraction. So in parentheses here, I'm going to multiply 4 and 2 together to get 8. And then I'm going to multiply 2 and 4 together to get 8. Which gets me 0. Okay. Well, 0 squared, that's what we would do next. 0 squared, what is 0 squared? 0. And now all the other, I just have multiplication left. I don't have any other operations left. So anything, this would technically be 6, anything times 0 is just 0. Okay. Let's do another one. I'll use different variables here because they tend to use different variables. We're going to say, those are my values that my variables equal. Again, as the expressions get more complicated, you still approach it the same way. So we're going to still, whenever we see an A, put in a 1. Whenever we see a B, we're going to put in a -2. We're going to put in 3 for C. Might seem kind of tedious to do this step by step, but I'm also preparing you for a high pressure test where it is important that you go slowly so that you don't make simple mistakes. Especially with a problem like this, it would be easy to make a simple mistake. Okay. So put the values in where they belong. How many sets of parentheses do I have? Well, main parentheses, I should say. From the original problem, I just have one set, right? Which means down here, as I start multiplying stuff together, I need to figure out what's in those parentheses first. So that's why I'm going to concentrate. 3 times negative 2 is negative 6. 5 times 3 is 15. Negative 6 minus 15, still working inside the parentheses, will be negative 21. Okay, so order of operations, we've taken care of the parentheses. The next thing on our list would be taking care of exponents. I only have one exponent, so I have to take negative 21 and square it. What do you get when you take negative 21 and square it? It's going to be a big number. 441. Okay. Now, you have to be careful here because you're taking negative 21 and multiplying it by negative 21. If you were to, in your calculator, just put negative 21 squared, because this is what happens with students. I guarantee you that they're giving you an answer that you would get if you did this, but they go like this. Negative 21 squared. So that gets you negative 441. But shouldn't you get a positive? Yeah, because in the calculator, you have to put parentheses, otherwise it doesn't include the negative when it squares. So just be careful to do that. Alright, so that becomes 441. Okay, and then we take care of multiplication left to right. So this would be 4 times 1 times 441, which gets me a pretty big number. Again, 1,764. 2 times 3 gets me 6. So my final answer would be 1770 at the end. Okay. Those are pretty straightforward. Any questions on either of those? Go ahead. Okay. We're working on solving just like simple equations, and then we're going to use this as like a jumping board to some of the next standards after this, which have to do with like percent and finding percent and lots of different kinds of equations. Alright, when solving equations, there's a few important things to look for right off the bat. You must look for parentheses. So order of operations still apply with an equation, and parentheses is always where you start. So that's kind of when you're just scanning over a problem, look for parentheses, because that at least gives you somewhere to start. If you see some, this is where you start. By using the what property? Anybody? Starts with a D? There you go, distribute it. Okay, so some steps you can follow in solving equations. If this is a standard where you feel a little bit shaky, these are just, this kind of gives you a plan of attack. You start with the parentheses. And I'm going to keep the directions pretty simple here, but you start with the parentheses and you distribute. The second thing that we always look for are like terms. And if you have a multi-step equation, you usually have like terms on both sides of the equal sign, and so we deal with both sides separately. You add like terms, or combine like terms, maybe that's a better way to say it, combine like terms on both sides of the equation. Okay, so this is like separate. We do that first on both sides. And then you combine like terms on one side of the equation. What I mean by that is if you have an x on the left side and an x on the right, you want to get them both together on one side. And I'll put in here that this is usually done by adding and subtracting. Remember, the order of operations still applies here, so we take care of that. And then the final step here, divide or multiply if necessary to get the variable by itself. Sometimes when you combine like terms, you end up still having like a 3 attached to your x or something. So we get rid of that by dividing. Okay, so we're just going to do some simple single-step equations. Single-step equations are equations where you don't have x's on both sides. You'd maybe just have it on one side, and so it only takes really one step to solve it. Okay, so we're going to look at one like that. This might seem kind of simple to some of you, but there are problems on the ACT that are like this sometimes. So, I mean, they're usually hidden within others, but this is a skill that you have to be able to do. All right, so the first thing we do is look for parentheses, and whenever there's parentheses, you usually have to distribute something. So what do I have to distribute? 3. The 3. So I'm going to distribute the 3 through. Distribute means that every term inside the parentheses gets multiplied by 3. So you get 6x plus 12 equals 10. Okay. Then we combine like terms on both sides of the equation. So if you look on the left, like terms are same variable to the same exponent. So we don't really have anything like that over here. There's not two x terms. There's not two separate numbers. So that's fine. And we only have one value on the right, so we don't have anything to combine there. So then we combine like terms on one side of the equation. My like terms, if you look at the whole shebang, are these two numbers, right? They're both just plain numbers. So I'm going to combine those together by getting the 12 over to the right-hand side of the equation. Since it's positive, to get rid of it on the left, I subtract it. And whatever you do to an equation, you do to both sides to keep it balanced. So you get 6x equals, what's 10 minus 12? Negative 2. Okay. And then we still have something attached to the x. We have 6 attached to the x, so we're going to go ahead and divide by 6. Because they're being multiplied, so to break up multiplication, you divide. 6 divided by 6 is just 1. And negative 2 divided by 6 gets me negative 1/3. Yep. And they will always reduce their fractions. So if you figure it out and your answer doesn't match what they have, see if you can reduce your answer. A lot of times that's what happens. Okay, so solving multi-step. Let's go with and I'm going to add in a little fraction here too. Okay. So I'm making it a little bit longer. but you still follow the same process. Okay, so where do you start? Parentheses. And when you see parentheses, we're going to go ahead and distribute. So, working left to right, that's what I'm going to start doing. Distribute the 4 through, and I get 8x minus, what's 4 times 5? 20. Okay. Then I'm going to distribute the 1/2 through. Now don't let a fraction freak you out right off the bat. Think through it logically, because especially with a nice fraction like 1/2, a lot of times doesn't make another weird fraction. What's 1/2 of 4? 2. So 1/2 times 4 gives me just 2x. And then 1/2 of 1 is 1/2, so yeah, I still have a fraction, but we're okay. And then on the right-hand side, I don't have any parentheses, so I'm just going to go ahead and repeat it. Then I look at both sides of my equation and I combine my like terms. Over here, I don't have any like terms on the right side, but I do have some like terms over here. I have 8x and 2x I can add together because they're both x terms. There's 8 x's, 2 x's, so I get 10 total. And then negative 20 plus 1/2. If you're at negative 20, so think of the number line. If you're at negative 20 and you add a half, where are you now on the number line? Negative 19 and a half. So you could write it like that. We could write it as a mixed fraction because you could get common denominators, which would be 39 over 2. Good. Does everybody know how to make this a mixed or improper fraction? Where you do the 2 times 19 and add 1? Yeah? Okay. Yeah, let's actually do that. Because these are pretty simple fractions, but if they got any more complicated, you'd have to do it with improper. So, what did you say, 39 over 2? Okay, 39 over 2, which is the same thing as 19 and a half, but we're going to keep it. And then that stayed the same. Okay, so now we have like terms. We have an x on both sides, and we have a number on both sides. So we have to combine them. Now, it's your choice what direction you move, but one of these terms we're going to move to the left side, the other term we're going to move to the right to get our terms together. So I usually take the lower x term and move it just to keep my x positive. That's just my typical thing I do, but you don't have to do it that way. We could subtract 10x from both sides. That'd be fine. But I'm going to move this over here by subtracting it from the right, which means I'm going to get this over to the right, so I'm going to add 39 halves. Okay, so I'm subtracting 3x, I get 7x. Now, whenever you're doing fraction work, I usually do fraction work off on the side so that my problem doesn't really become super crazy. But I should say, well, I won't say that right now. So 2 plus 39 over 2. This is what you're doing. Okay, you're adding 2 wholes, and you're adding 39 halves together. To do this mathematically and keep it as a fraction, we have to get common denominators, which means this becomes 4 over 2, because you just multiply the top and the bottom by 2. Is 4 over 2 still 2? Yes. We're not changing the value. You cannot add fractions and change values. You just change the way that it looks. So 4 over 2. So 4 plus 39 gives me 43. Okay. So 2 plus 39 halves gives me 43 halves. And then normally we would divide by 7, correct? To get x by itself? Okay. You have a choice when you divide in these scenarios. You can divide by 7, but if we divide by 7, you're taking a fraction over here and dividing it by another fraction. It just gets kind of messy. You can divide by 7, or you can multiply by the reciprocal. It's the same thing. It's just if we multiply, instead of dividing by 7, if we multiply by 1 over 7, that makes a little bit more sense when we get to the right side. Technically, you're still dividing by 7, because that cancels out. But now over here, we don't have a weird fraction over a fraction. We just have two fractions we're multiplying together. So 43 halves times 1 over 7, multiply across the top and the bottom, and you get 43 over 14. And that does not reduce, so you just leave it as is. Okay. I think that might be where we end today. Do you guys have a whiteboard app, or do you not have a whiteboard app anymore?
Nope.
You had to delete that one, but do you have another one that you can use? If you have Educreations, do you have that one? Okay. You can pull up a whiteboard app to practice a few problems, or just make a new page note taker. That would work fine too. You just have to, you could delete it afterwards. Alright. And I'm going to give you two problems here. I'm going to give you a simple one-step equation problem. And then I'm going to give you a multi-step one with some fractions. We'll see how you do. Okay, here's the first one. Make sure you show it to me before you move on.